Welcome to today's knowledge sharing webinar, the Bangladesh Forest Inventory, History, Design, Operation, and Key Findings of Bangladesh National Forest Inventory. My name is Tauhidor Rahaman. I'm working for Bangladesh Forest Department. So this is today's our presentation's outline. We have a background of National Forest Inventory. And later on, we'll talk something about National Forest Inventory 2016, objective of the forest inventory. We have 5 zones across the country, so we'll discuss a little bit about the zoning, and we'll discuss a little bit about sampling design, plot shape, and sampling intensity. And we'll discuss a little bit about the technical design to how the measuring parameter has been fixed and the threshold was determined. We'll talk a little bit about the equipments that have been used during the national data collection process, survey design with open forests, the main activity of National Forest Inventory, and result. So first we'll focus on the background. Forest inventory in Bangladesh. Forest inventory has started from 1958 in Sundarban, and several times it has been took place in Sundarban zone.
Okay. So national can be across the whole country in 2016. So some key information about that. Bangladesh has been divided into 5 ecological zones based on the similarity in forest condition, soil type, and some other parameters. And systematic stratified random sampling was used in designing BFY. And in total, we measured 1,858 plots across the country. So open forest platform has been used for data collection. This platform has been developed by FAO. So we use this for survey design and data collection procedure. There were total 12 teams for data collection and 4 QQC teams for quality check and quality control. So some important dates: we had started planning of land cover mapping and biophysical inventory in 2012. And physical work started in early 2016. Land cover map had started in June 2016 and ended December 2017. Biophysical data collection had started in December 2016 and ended in April 2019. Socioeconomic survey had started in January 2018 and ended in November 2018. BFI report approved by the ministry in June 2020. So our objective: provide information on current status and trend of forest and tree resources, to provide baseline information for national forest monitoring, to assist national scale management planning, policy decisions, and reporting requirements, including UN date, and link between forest resources use and forest status to assist in evaluation of ecosystem services, support management objectives within subnational ecozone. So this is our ecozone. So in the right side map, we can see the 5 ecological zones, which and based on the forest soil, and water. Several opinion and place determine this within the Bangladesh. Sampling design, AP certified with the institute sampling intensity within the zone was same. With each ecological zone was further conducted to reduce the sampling error. And we also considered the precision requirement, assessment of cost for remuneration, transportation, and equipment, and minimize the weighted average variance of the key metrics subject to a fixed inventory budget. So we divided 0.5 latitude and 1 longitude. So then we have created two countries and have determined within the hexagon with individual plot. One plot is selected for each hexagon by random sampling, and plot in water was not considered. So in left side, we can see the distribution of our sample plot. And here also different colors represent zone of Bangladesh. So for example, here coastal, we had 113 sample plot on land, 217 in the world is 173 in on land and 85 in water. So sampling design, intensity, and the average distance between plots. We did it according to the ecological zone. And say for example, hill forest total area was 1714 into 1000 hectares. Number of plot was 429, and the sampling intensity was 0.014. And we have measured the distance in straight line and traveling distance also. So in hill zone, the distance was 4.43 in straight line, which was 6.70 in village zone. So this is the demo plot distribution within has shown in the Google Earth images. So this is another example of national forest inventory. So here we can see sample plot. It consists of 5 subplots. So for 3 zones, there was 5 subplots for one cluster plot. But for Sundarban and the coastal zone, there was 3 subplots in a single plot due to their homogeneity and similar forest characteristics. So we have used circular cluster plot for 5 subplots, as I said, is for hill, chal, and hills, and coastal plantation also, and 3 subplots for Sundarban. So there are 3 types of plot within the subplot. One is 19-meter radius large plot, and another one is 8-meter radius, which we call medium plot, and another one is small plot, 2.5-meter radius. So let's see each subplot details here. So in each subplot, the green circle is for 19-meter radius. So 3 above 30 centimeter diameter, we count, we took measurement of those 3 within this radius. And red circle is the medium plot, where we took the measurement from 10 centimeter to 29.9 centimeter. And the small one is from the subplot center, we go into 90-degree direction, 5 meter. And from that 5 meter, we create a circle, create a plot within 2.5 meter radius to count and to measure, take measure for seedling and sapling. And here we can also see food transit along the 45 degree, 135 to 25 and 315. So this food transit is to count the down the material. So we had count fine woody debris, and we have took measurement of the coarse woody debris. From the subplot center, if we go in 270-degree direction, and after 8 meters, we took soil samples from there. So we took bulk density, sample for bulk density, and so we took sample for soil texture also. And in the same place, we took the litter from by 1 meter grid. So equipment that have been used in National Forest Inventory, as I said, we have not used any paper. It was fully digital data collection process. So we use this Panasonic rough tab. This is waterproof, and it can took geolocation with very accurate data. Even it can reach up to 1 meter in geolocation data. So we use this tab, and we have used this Garmin 64 GPS and coordinates. We use this clinometer. We have used this to measure the azimuth and also used to get the slope. And we also use this mirror compass to get the azimuth or bearing. So we use densitometer to measure the leaf cover. In the middle diagram, we can see a few red lines. So from the subplot center, we walk 5 meters in 4 directions: in 360 degrees direction, 90 degrees, 180, and 270 degrees direction. So after every 1 meter, we took a measurement like we can see in the diagram. If the diagram is cover more than 50%, then we count as a 1. And if it is less than 50, then we count as a 0. And this is how we can calculate the exact percentage of our leaf cover. So we took DBS and DBS height. We all know it's 1.37 meters. And we use the two-pulse laser range finder to measure the height. So if we see the left figure, there are 3 steps. 1 is distance to trunk, and 2 is angle to base of tree, and 3 is angle to top of the tree. And it will give automatically the total total height of the tree. And we also use DME. It is very useful tool in the circular plot, because if we put this type of transponder in the center of the plot, as we see the right side figure, there is a yellow dot, meaning the center of the DME, and we can walk through the periphery, and we can take the measurement of horizontal distance. And by this, we are able to understand whether the tree is within our plot size, or within our plot, or outside of our plot. So this is very useful tool in every case. And one latest technology that we have incorporated in our National Forest Inventory is RFID chip. So later on we'll see we'll have some discussion about the reference point and witness object. This witness object is to find plot location in later, and we have those point tag with the witness object, and we had inserted those strips into the tree, and we can get the reading from this machine, and it is able to see the plot number, is able to give us the plot number, subplot number, lat long, and all necessary information which has been transferred to the RFID chips and inserted into the tree. So for survey design, we use this open forest. So open forest is developed by FAO. There are several tools like open forest desktop, open forest collect mobile, then open calc, open sepal. So for our purposes, we have used 2 of their tools. One is open forest desktop for survey design, and another is open forest collect mobile to get for the data collection with the tab. So later on, I'll give this link into the chat box if anyone interested. He or she can explore this. Let me put all together. Okay, you can explore this link and you can get some more idea about this. And then so comparison to paper form. Actually, why we moved with the CAP or digital platform instead of paper platform? Because validation in the field. So in this digital platform, we have this opportunity to error check, and we can make some mandatory fields so no one can able to. They have to fulfill that information at the field itself. Otherwise, it will not go. It will not go further. And there are some there are no non-relevant fields. Integrated food and species list. Say for example, if we allow people to write the species name, so the spelling will be different, and the way they will write. So in database, it will make a problem. It will create a problem when we deal with different names. But we have opportunity to incorporate our species list in this platform so that they will just see in drop-down list and they'll just click to get this species. And we can submit this data to Google Drive. So no secondary data entry required. Directly we can output as a CSV file. So how does it work actually? So this is the interface of Open Forest Collect. And here we can see in the left-hand side, there are some entry, parent entry, like plot location, plot record. And within that parent entry, there is some subcategory like plot date, plot arriving from, plot departure time, plot due. So if we think in that way, there is heading and subheading. So we can incorporate in that way. And there are some red dot. Red dot means the required. So we cannot proceed without completing this site. And this is very smart navigation. We can go to the next page, next thing by swiping in hand, in fingers. And there is possible to get some entry directly from the above menu. So error check and validation for the subplot number. As I discussed, that if I plot in mentioned accept Sundarban. So if I put here 6, it will not go because this is the validation. He knows that it knows that the subplot could not be more than 5. So this sort of logic we can set here. And one more thing, like bold height and total height. So if we put some bold height higher than total height, then it will not accept, and it will give us word that bold height cannot be higher than total height. Similarly, if we want to measure the azimuth and if we press 365, so it will give us word that this could not be 365. So this is how it helps us to avoid those mistakes from the field. So main activity of BFI, first we developed national land cover map in 2015 from 6-meter multispectral spot 6 image satellite imagery. And second was biophysical data. So they are a little bit tricky to read. So RP with location. RP means reference point. So when we visit and plot, first we set a reference point. It could be electric pole, it could be any permanent structure, or it could be anything different than that land feature. So we take that RP, we take that description of that RP, and we take the picture of that RP and location of that RP. So when you go for revisit, easily we can see that RP, and from that RP we can look at the plot center. And then we define the land feature description, land feature object, and land feature proportioning if there is more than one land feature. Then we say with this object in the subplot. So we'll have separate slide on that. We'll discuss details how and why we are taking that wetness object. We measure canopy cover, tree species, dBAs of bearing, horizontal distance, the sapling species name, sapling dBAs, total height, horizontal distance, and azimuth from the sapling center. And for seedling, we just count the seedling number according to species. And litter collection, we collect some litter sample. Downwoody materials, we took all the measurement of coarse and fine debut wood materials, and we collect soil sample. And we have created access database and incorporated with some R programming language. So as a result, when we collect data from the tab, from the open forest, we can export directly as a CSV. And from that CSV, we can directly generate the plot report, and we can do the data cleansing in this access database. Let me show you one example of one plot report. So this is one plot report from 505 from Sundarban. So here you can see each and every information. As I said, this is RP reference point, and this is details of that reference point. And this is our space map to entry on the plot, and this is the land feature proportioning map. And later on, if we go down, scroll down, the picture of the soil sample, and you see the wetness object. Say for example, subplot 2, the wetness object is tree. One is tree, and we have distance, bearing, dia, and tag number of those 3 specific wetness objects. But for other trees, we don't have this tag number. So we have each and every information of that plot. So as a result, we can generate plot-wise report immediately, and we can do data cleansing. If we need any correction, we can do over there. And then another important activity was socio-economic data. So the questionnaire survey has been conducted considering fuel consumption rate, livelihood to detect forest dependency, wildlife status, and suggestions, their trade and suggestion, deforestation and forest degradation trend, return of that deforestation and degradation, management gap, and suggestion, and people engagement in the natural resource management, their opportunity, gap, and suggestion. So we also developed an app for plant identification, especially for this National Forest Inventory, which we call BGD3. So if we do not know if we are not able to identify any tree, then we can take help from the BGD. We can search by local name, or we can search by the phenological characteristics. Then we also developed country-specific allometric equation for the major species, and we had developed 28 allometric equations for the National Forest Inventory to use country-specific data. And another important, as I discussed, RFID was very new to introduce, and we have inserted those RFID in the wetness object, and mostly in trees in digital to detect later. Then we have collected DGPS points of plot center to make those permanent sample plots. As we know, the GPS are able to give us very precise plot centers, maybe 2 centimeter accuracy. It can goes up to that. And we also developed a BFI manual, standard operating procedure for that. So we also developed countrywide soil sample archiving at Khulna University, which has been collected during this data collection process of National Forest Inventory. So establishing wetness object, why it's important? Because when we collect those data, so we collect key information from the center, like bearing of tree, then horizontal distance of tree, each and every information we collect from the subplot center. So later on, if we want to visit those plot again, it's very important to find out the exact pinpoint location of subplot. Otherwise, we'll not be able to compare with the previous data, with the previous information. That is why we usually take key witness objects. It's some sort of triangulation. And we, as you can see in the left figure, there is a tag 535. So we put those sort of tag in the witness object, and later on, from the witness object, we measure the slope distance and bearing, and we do the triangulation. And from the triangulation, we are able to find exact pinpoint center of that sample plot, and we can measure. We can take measure again and again. So this is the cross-axis case. This was also mandatory for us for each individual plot. Field team need to make a sketch plot so that later on QQC team or any other team will be able to identify those plots easily. So this is the land feature in the plot. So for example, if we have more than one land feature in a particular plot, then how many % of land feature belongs to which land feature? And in this case, we are using this form, and from each subplot, there are 256 grids, and each grid is 2 meter by 2 meter. So from center, subplot center, we take the bearing and distance of the edge line of different land features. Then we put into this form and we get this red line. And from this red line, we are able to calculate very precisely how many percentage of land feature belongs to which land feature. And later on, it really helps us for the calculation. And see, here are some other witness three black circle indicating 3 witness objects. This is also measured according to bearing and distance from the center. And in the upper left side, there is a cross button which is indicating the reference point, location of reference point. So this is similar, just incorporated to all other witness objects and some tree also. So key result, our BFI result has been focused on reported on the basis of 7 criteria and 47 indicators. So those 7 criteria are forest extent and tree cover 10, biological diversity and conservation, growing stock, biomass and carbon, management and ownership, tree and forest disturbance, support for sustainable forest management, tree and service of livelihood. So this is the key result of our land cover map, and forest cover is 12.8%, forest 41% country land area. So this is our land cover class. According to land cover class, we can say the percentage of national percentage, like hill forest is 4.64%. and shrub scattered is 4.164%. The total is 12.767 or 12.8% of total country area. So number of trees from our national forest inventory, we were able to identify 319 different species, and among those 352 was from native and 38 species was introduced. 12 globally threatened species found in the sample plot. So stem density was higher in the Sundarban, as is 661, Kabustibi also, and we also have the basal area, which is also highest in Sundarban, it's 22.29 meters per hectare, square meter per hectare. And key result generation, this is also have been considered according to zone. Seedling density was highest in the Sundarban, like 20,942 seedlings per hectare. Actually, we counted all seedlings below from the 10 centimeter height to the DPA less than 2 centimeters. So that is why actually we got this much. And second highest was in Chal. So biophysical above ground biomass, total national above ground AGB of the country is 387 million tons. And Sundarban mangrove has the highest above ground biomass density, which is 98.4. And this is 3.8 times higher than the national average. So Mangifera indica, Hereditary and Sweetener meriguna are the top 3 species by above ground biomass. And left side, we can see the above ground biomass mapping according to zone. And we can see in the lower left side, in the Sundarban zone, it's highest. So clear biophysical growing stock is also highest in the Sundarban, like 39.44 million meter cube. But per hectare is 97.75, which is highest in Sundarban. So national carbon stock, we have considered 5 carbon pools, and we have considered carbon above ground biomass, below ground biomass, and we have considered the downy materials, liters, and soil organic carbon 30 centimeter, soil organic carbon 100 centimeter. This 100 centimeter, it was only for the mangrove area because those was mudflat and the intertidal area. But for the rest of the area, we have considered this 30 centimeter area. So our country total is 1275.55 million ton. So biophysical forest carbon stock, forest area holds 21.5% of the total carbon stock in the country. Hill forest and mangrove forest alone held 9.7% and 5.2% of the total respectively. So we also did the socioeconomic survey. And from the survey, we can see that 95% of the respondents received shade from the tree and natural forest and natural windbreak. So those are the things, those are the benefit we get from the tree according to our respondents. And 65% women are involved in with collecting primary tree and forest products. So economic value of primary products from tree and forest, which was really highest in the peach, shrimp, and crab. And the second one was bamboo, and third one was quailwood. So use of BFI information, baseline and monitoring of 6 indicators under Sustainable Development Goal 15. Reporting the global forest resource assessment, particular result used. And report to the UNESCO World Heritage Site Authority, because as Sundarban is the one of the World Heritage Sites, so the committee was concerned to some other pollution issue, and we have used this information, used this data to report them. So use of BFI information, also forest reference level, report submission to NFCC. We have used very particular information from our National Forest Inventory. Monitoring land degradation, and national and subnational forest management plan. So this was my presentation. So I want to share some link with you. Just allow me a few minutes. So there are some links of BFIS, which stands for Bangladesh Forest Information System. So I am copying this link. You can explore and you can get more idea if you need, and you can get the National Forest Inventory report, standard operating procedure, manual, and even you can get the R code, which we have been used for the data analysis. So let me show you one. Okay. So this is our Bangladesh Forest Information System. If you scroll down, you will see forest assessment. And under forest assessment section, you'll find forest emission factor database. You'll find BFI geoportal, Bangladesh forest inventory, and plant species identification. And from the Bangladesh forest inventory, you are able to download your report, our forest inventory report. And knowledge management, there is BFI e-libraries. If you click into that, you are able to download all other resources like publication. We have 542 publications, training materials, maps, even our script. So if I click here, so I script for Bangladesh forest inventory data analysis, even socio-economic data quality assurance and quality check are script. So you can go through, and if you need some information, you can explore from there. So thank you so much for your kind attention. This is my communication address. So if you need any help, if you need any clarification or any support, anything you want to know, please let me know. I'll try to answer you.
Thank you very much, Tauhidor, for your presentation. It was very informative, and you tried to describe to everyone really all the process. I see there is no questions in the chat box, so I just want to remind the participants that you can ask questions in the chat box in this webinar. So just now I wrote the question to Tauhidor because I asked a lot of questions before the webinar. So please, guys, if you have questions, do not hesitate and ask questions in the chat box. And if you can answer my question, you can find out it also in the chat box, please. Okay, Dor, you have now 2 questions.
Yeah, please.
So first one, which features like minimal area density or height, diameter, etc. should have plants to call them forest, and can shrubs be considered as forest?
Actually, for this, I need to refer our FREL report. So in our FREL report, it's clearly defined the forest definition. So there has been some threshold. Maybe you can go. There is section 3.1 where it has been set up all the thresholds, like it has to be at least 2.5 hectare, and the height should be 5 meter or able to reach 5 meters, something like that. So in that case, we have very precise definition for that. If the land is not agricultural land or not in the rural settlement, then we consider as a forest. But it has to fulfill another threshold, like the coverage and the height, all those things. Thank you.
Okay. Here we have a next one from Mr. Irene Parvin. Nice presentation. Would you explain a bit more about different types of satellite imagery? Did you use current image or archive imagery from satellites?
For land cover map, we have used the 4.6 image of 2015. And for the plot location and plot thing, that we have used the recent image from Google Earth. Was this question like this?
Hope so. So
okay.
you use the current
and one more thing to Irene ma'am. This time we are also using the Google Earth engine to develop land cover map for 2020. So maybe we can incorporate those to we can share those things with you. Thank you.
Mm-hmm. The next question from Frederick Moka. Thank you, Tauhidor, for the very informative presentation, and thanks again for the great work you have done in Bangladesh. Is possible to simplify the open forest collect and customize it for use by the rural communities in collecting data for community forest carbon monitoring?
Thank you, Frederick Mokua. I'm really happy to see you here. Actually, Open Forest Collect, we can incorporate to collect the data, biophysical data that we need to collect from the pit, and it will upload directly to your Google Drive. But for carbon monitoring, maybe you need to go for some analysis in R. There are some other tools that could be incorporated with that, but Open Forest Collect itself maybe not able to do up to that level, but you can use to collect your data. Thank you.
We have another question from Irene Parvin. Why biomass map shows that more biomass is in Sundarban rather than Chittagong hill tracts? Why biomass map shows that more biomass is in Sundarban?
Firstly, the highest biomass showed in the Sundarban because Sundarban is a world largest mangrove forest and which is mostly undisturbed. And you will not see that much forest degradation or deforestation in the Sundarban. It's not in alarming rate. And we can say that forest in the Sundarban is almost intact, and that is why we are getting higher biomass in the Sundarban. And also getting little higher in Chittagong hill tract as compared to Shal forest, because Shal zone is mostly deforested and degradation is taking place in every time. So that is why hill forest is also degraded prone area, and even deforestation, shifting cultivation is taking place, but it's little bit higher as compared to the Shal zone. Thank you.
Thank you, Tauhidor. We have another question from Katerina Fedina from Ukraine. Thank you so much for the great presentation. How you choose where should be located S&M plots? Is it randomly? Maybe I lost some information about that. So is it randomly choose plots?
Actually, it's not randomly, it's systematic randomly, we can say, because first we have make a hexagon systematically across the country. So within that hexagon, we have created that random plot.
So it was the last question in the chat. If there's someone who want to ask question, you have chance, because we still have like 7 minutes of scheduled program. If there will not be any questions, I would say thank you very much, Tauhidor, for your efforts, for the great presentation, and some people more are grateful for your presentation and for arranging this event, and especially to you as a speaker for sharing really interesting and important experience from your side, from your unique country. And here you can find also some thankful words for a great work you did. For example, Manal Hafni, he wrote you that your work is great. Also, he is not involved in forest research, but it gives good information about forest ecosystems.
Thank you, madam. Thank you. I always take inspiration from them.
I would be happy if all of you could spend a few seconds to fill up the feedback form. Maybe you can leave some more questions in the last box of the form. In this case, Tauhidor will be able to reply this question, and we will share with all the participants who was joined us today. And you will find out a link to the recorded video of today's webinar in your emails. So wait 1-2 days and you will find out in your email boxes. I don't see any more questions. Tauhidor, if you have some last words, you're welcome to do it.
Actually, I would like to convey my heartfelt gratitude to your university and you to organize such a wonderful scientific event. And also would like to extend my heartfelt gratitude to those participants who have attended this program. I'm very happy to be with you. And if you need any clarification or any further question or any resource regarding this National Forest Inventory or even GIS remote sensing, please feel free to ask us. I've given my address, email ID, and WhatsApp. I'll be really happy to reply. So thank you so much. Thank you.
Thank you. And also we'll share the useful links that Tauhidor put it in the chat box here. So yeah, wait for the email with all the useful information in next few days. Thank you very much and have a great evening and weekends. And you're welcome to another meetings we will organize together. I hope so. So good luck.
Thank you, sir. Good luck.
Yeah,
Thank
goodbye
you.
to everyone.
Goodbye to everyone.